All right, so that is the 2-point list measure. So now we've checked our flushness for our side panel. But one other thing about this side panel is it's got a nice 4-way control right here, nice tight hold to a bolt. And then if I go over here, I've got a slot going to a bolt in here, which is hidden. But we also have a lot of these clearance holes going around. And with how I envision my assist lift being assembled, I'm picturing that my assembler, to make his life easy or her life easy, they can just screw in, and torque down this one over here and this one over here, and then worry about just sliding all these in real quick later. So I want to make sure that if he or she torques down these 2 bolts, they'll have enough clearance to make sure that an M6 bolt can get through these holes. So that's going to be our next objective with this analysis here. So our output number 4, I want to check to make sure that my pattern of perimeter clearance holes, I want to make sure this is enough clearance in it such that my M6 bolt is going to be able to fit through without adding any locating effect to my my side panel here. So to do that, I'm going to use what's called a circle interference measure. And this is I find an incredibly common measure in 3DCS. I'm using this one all the time. And its best use is checking the minimum clearance between 1 or more pin and hole pairs. So much like the 2-point list measure, I'm taking a list of object points and a list of target points.
Again, they have to match.
Exactly. And again, I want these to correspond across. I don't want these to cross at all, or else it's measuring from, pin 1 to hole 2, and pin 1's probably not going to get into hole 2. It's probably not how this is going to work out. So my primary inputs are just one list of the pins and holes, and then a second list of the corresponding holes or pins. And these are going to be best used for checking the size of clearance holes. And when painted with the pattern move, it can actually check to make sure, or check where the pattern move is kind of falling out of spec, where it's having a tough time solving. In this case, I did not pair it with a pattern move because, as I mentioned, I don't want these pins and holes to be doing any locating. I want my 4-way and my 2-way doing the locating. So in this case, I have my side panel moving to my platform, only using my 4-way over here. You can see I've got those 2 arrows over there. Then I have the 1 down arrow over here representing my 2-way. But now I want to check all of those other holes that I have in here to make sure those fit. So I've added a circle interference measure. And when I highlight that one, you'll see that all those points are highlighting, and it's telling me I'm measuring from this one to this one. So I have a from 2, 2, 2, from 3, 3, 3, and that's what all those letters are saying. That might be kind of challenging to read. So for this measure again, it takes a group of objects here and then a corresponding group of targets. And one important note is it doesn't matter if you put your hole in object or pin in object, as long as the corresponding thing across from it is going to be that corresponding hole or pin. So I got to have all pins over here and all holes over here, or all holes over here and all pins over here. I'm pretty sure you could even, mix and match them. I wouldn't recommend that. That sounds like a bookkeeping nightmare. But you could if you wanted to. The measure is going to allow you to do that. And so the most common type you're going to use for measure type is going to be min clearance. Similarly, we do have other options here. Max clearance is going to return to you it's not a maximum value of clearance that you're seeing between one pin and one hole. It's like, I'll just go to the help manual and that'll give us an image of what I'm talking about here.
So it's interesting, you did just cover something that I wanted to mention is in all of our measurements, you hit the button, I couldn't see it.
Yes.
But the dialog box has, every dialog box has a button that will go directly to that area in the help. And so that's what he did.
So for this circle interference measure, I clicked on this button right here, which has a little help icon as well as a circle interference measure icon. If you're in CATIA, it's not going to have this little question mark here. It's only going to have this icon right here, but it's going to be in the same spot in this MTM. If I click OK on this one, I can go to the point distance one. See, same spot, same icon idea. So if you just click on that for any of your
Moves,
MTMs,
tolerances, or measures.
it'll take you right to it. And so then in the help file, I have this image here, which is best used to explain what max clearance mode is. So for each of my pinhole pairs, 3DCS is measuring the minimum clearance between those two. So for pin 1, hole 1, I have 0.42 millimeters of clearance. For pinhole, or pin 3, hole 3, I have 2.33 millimeters of interference, so negative clearance. What the min clearance option is going to give you is the minimum number that it saw for all of your pairs here, and what max clearance is going to tell you is the maximum number that it saw for each of your pairs here. So,
and this is one build that you're looking at.
Yeah, exactly.
So it's going to do that every build. This particular build, the max clearance is the 0.42, and the min clearance is the interference.
Yep. So it's not returning to you any of these like max clearances. Like if you wanted to say like, well, I've got my min clearance over here, what's my maximum clearance, to be kind of the opposite of it. Okay. So use kind of the opposite of it. But so that's what the max clearance mode is, and we're going to go back to our model right now. And so that's the circular interference measure. If I go ahead and I build this, and once again we have this current button. So at nominal, I have 1 millimeter of clearance between that pin when that pin is centered in that hole. But if I start deviating, we'll see this number is never going to get greater than 1, because there's always going to be somewhere where the pin is shifted such that there's going to be a less than nominal clearance. And sometimes I'm even seeing that I have some interference here. So if I ran my analysis, I could find out how much interference I'm seeing, and could either change the positional tolerance or change the nominal clearance hole size to get rid of this interference I'm seeing, since this is out of spec.
So, and it's key to note that if you saw from the help picture, this is a radial measurement. So if you get an interference of 0.2, to solve that, you would have to make your hole bigger by 0.4.
Yep.
Diametrically.
Yep. And I guess last thing to point out here is whenever you're using the circular interference measure and you're checking for interference, just make sure you change your spec mode to absolute and get your lower spec to be 0. Upper spec isn't too concerning at that point, because you can never have too much minimum clearance between a pin and a hole unless you're trying to figure out what size washer to use. And then I guess
this is a common error that you don't get until you run your results. So we were even talking, and it might be in our database, to try to change the default for circular interference and virtual clearance, changing the default to absolute.
Actually, for all measures, the default should be absolute, because if a measure is referenced in another measure or move or tolerance, you want those spec limits to be absolute. That's probably why your in-spec wasn't working earlier. So, hi, this is Brenda.
Hi, Brenda.
Hi, Brenda.
Yeah. So if you're doing a simple model where each measure stands by itself, relative is fine. But if you're using the combination measure or measure equation, or if you're referencing a measure in the conditional logic or interference logic fields of a move, you want that spec limit to be absolute.
And then how does circle interference work with floating? If when is floating active or when floating is not active?
So it's a good question. None of the pinhole pairs that I used in my circle interference measure were used in a move. So none of them would have float involved in them.
So the float is involved in the four-way, two-way, which is shifting the panel.
Yes.
And then the circle interference is just checking the other holes to make sure that once you sink your four-way, two-way screw, can you just randomly throw all the other screws in?
Mm-hmm.
So the idea, if you didn't have the four-way, two-way locators, then in the assembly document, it would say, please loose fit all screws first and then tighten them down. But with the 4-way, 2-way, you can sink those 2 screws and then randomly suck down all the other screws if this circle interference measure passes.
Yes. Which is the goal of my design here.
Right. The goal is not to have to loose fit all those screws before you suck them down.
Yep.
I hate that with assembly instructions
It's-
because I never do that. And then the last screw doesn't fit.
Maybe I should have done that, but
Right.